Hello, my name is Adam. In this video, we are going to learn how to make the Google Chrome Dinosaur Game, where the player guides a pixelated T-Rex across a side-scrolling landscape, avoiding obstacles to achieve a higher score. This tutorial will teach you how to implement side-scrolling, infinite generation, and high scores. Overall, it is a fairly beginner-level tutorial. If you need help at any point, feel free to join our Discord community where we can offer direct help. There's a link in the description of the video. Please consider subscribing to the channel if you like my videos. It really helps drive the growth of my channel. We're getting really close to 10,000 subscribers. Thank you. Enjoy the video. Let's start by creating a new project using the Unity Hub. In the top right corner, we can click New Project. Let's choose the 2D template since this will pretty much be a 2D game. At the very top, you can also choose which version of Unity you want to use depending on which versions you have installed. So for this tutorial, I'll be using 2021.3, which is the current long-term support version. Doesn't really matter too much which version you use. We won't really be using any special components or anything, so feel free to use whatever. Of course, you can name your project. I'm going to call this Dino Game, and choose wherever you'd like to save your project, and go ahead and click Create Project. From here, it might take a couple minutes to initialize, so we'll pick it up as soon as it finishes. All right, let's start by importing some sprites that we're going to use throughout our project. If you want to use the same sprites that I'll be using, you can download them from the GitHub project. There's a link in the description of the video. Upon opening that link, you should see something like this, and you can download the entire project from this code button here, and then you can download the zip. Of course, you can use git commands to clone the repo as well if you're familiar with that. Let's go ahead and unzip this project here. And then we can pull out the assets that we want. So in here, you'll find assets and then sprites. And we can grab these. Let's just sort by PNGs here. And I'm just going to take all these PNGs and I'm going to drag them into our project panel at the bottom here in Unity. And let's go ahead and create a new folder to organize all of these assets. So I'm going to create a folder called Sprites, and we're going to bring those all in there. Now, before I move on, you can also get the sprites themselves from Chrome, since this is the kind of Chrome browser game. If you go to Chrome, if you open up the game here in Chrome, and if we go to the Dev Tools, so we can go to this More Tools and then Developer Tools. If we switch over to Network, and let's actually refresh the page, it's going to download the assets that are used by the game itself. So for example, if we clicked on one of these, here's the actual sprite sheet that's being used by Chrome. So you could actually take this and save this entire image, but you probably need to use some kind of photo editing tool to pull out the individual sprites. But this is a more comprehensive sprite sheet. I'm not using everything on here in my version of the game, but if you needed the full sprite sheet, this is how you could get that. All right, so back to Unity. One thing we need to do is update some of the import settings on all of these sprites. So I'm going to select all of these, and here on the right in our inspector, we can change the settings for these sprites. So for one, I'm going to change the pixels per unit to 96. What that means is for every 96 pixels, it's going to be 1 unit in our world space in our game. And so all of the size of most of these images are, for example, 96 by 96 pixels. So when we place them in our scene, they'll take up exactly 1 unit. This doesn't necessarily matter what this value is, but it just kind of helps to keep things more normalized or consistent across all of your assets. So let's keep that at 96. For the filter mode, I'm going to change this to point. Usually for pixel graphics, you want point or no filtering. Otherwise, the pixelated style kind of gets filtered. It gets blurred, which we don't want for pixel graphics. And then from here, all of these images are really small. So we can change the max size to, let's say, 256. Let's get rid of compression. These are all really tiny sprites, so they're not going to really take up much space anyways. And that should be good for now. The only thing we need to change from here is specifically the ground sprite. This one's a little bit different than the rest. So I'm going to change the max size on this to 2048, I believe. Let me double check that. I believe it's 2048. No, so it's actually larger than 2048. So let's change this to 4096. And then this one we want to repeat instead of clamp, because it's going to sort of cycle. This ground sprite is going to kind of cycle as it, we're going to animate it so it goes left to right, and then it'll kind of cycle and continue repeating over and over and over again. We change that to repeat and we're good there. So that's it for our sprites. Okay, let's set up our scene with some of our game objects. And first, actually, let's go to our scenes folder. I'm just going to rename the scene here from sample scene to Dino Game. Feel free to call it whatever you'd like. And let's go back to our sprites, and let's maybe start with our ground sprite. So we can just take this and drag it into the hierarchy on the left. So create a new game object. It adds a sprite renderer component to that game object, and it assigns that ground sprite to it. If we go to our game tab here, we can preview what this looks like. It's very hard to see, so let's adjust some of our camera settings. First, let's change the background color. So let's set this to D6, D6, D6. Obviously, feel free to customize this to your preference, but that looks pretty good to me. And we're also going to raise the camera position, which will effectively lower everything else. We could change the position of the ground object, but I actually want to try to keep the y-axis value here at 0 for most of our objects. It'll just simplify some of our code. So keep that at 0. Instead, we'll change the camera position. So I'm going to set this maybe to 2. And then something else I want to change here is the size. If I make this larger, it in a way effectively zooms out the camera. And if I make it smaller, in a way it zooms in. So I'm just going to change this from the default 5 to 4. And I feel like that just looks a little bit better. It makes the ground sprite a little bit clearer to see. But once again, feel free to adjust that to your preference. So I think that's good for our camera and our ground. Why don't we go ahead and add our dinosaur next? So I'm going to take the idle sprite. I'm going to drag that into our hierarchy. We'll keep the Y value at 0, but we can change the X axis to position him on the left side of the screen. So I'll do -6. That looks good. I'm going to rename this to player. I'm also going to tag this as player, which will be important for some of our code later. And I think that's it for now in terms of our scene. The rest of these objects, like our cactuses and our birds, those are going to be spawned dynamically using a script, so we don't actually need to do anything else in our scene yet. So this is a good starting point. Next, let's get some of our player controls working. So really in this game, there's only one control for the player, which is to jump, so you can avoid the obstacles. You don't actually move left or right or anything. Or I guess that's sort of one of the things with the side-scrolling game. In a side-scrolling game, it's not the player that's actually moving. The player actually stays still, and it's the rest of the environment that moves to make it feel like you're scrolling to the side. But for our code, all we need to do is worry about moving up and down. So first, before we start writing that script, let's go back to our player game object and let's add a character controller. This will handle some of the physics and collision of our object. We could also use rigid bodies, but personally for this game, I don't like using a rigid body because I feel like it's easier to achieve the physics I want using just a character controller. A rigid body is intended to simulate real physics, as closely to real life as possible. And for a lot of games, especially 2D games like this one, the physics aren't realistic at all. And so sometimes it's actually harder to achieve the desired feel you want using something like a rigid body, which is intended to simulate realistic physics. So I'm going to use a character controller, which will still give us collisions and stuff, and it'll allow us to move the character, but it'll just be a little bit easier to get the feel we want. So if I go to the scene view here and I turn on my gizmos, I can see this green outline is representing the character controller. A character controller is really just a custom collider that then has some built-in functions for allowing you to move the object. And one of the other reasons we are specifically using a character controller here is because there's a built-in property that allows us to detect if our character is grounded or not. A rigid body does not have that. So it actually takes more code to use a rigid body because we have to do a custom raycasting to check if the character is grounded. Whereas for this, it's just built in. So it just simplifies it. Now we also need to set up our ground with a collider. So we actually stand on the ground and don't fall through it. Let's go ahead and go to our ground game object here, and let's add a box collider. Now this is a 2D game, but we're actually going to use the 3D version, the normal box collider, which is usually intended for 3D games. Same thing with our character controller. This is actually generally intended for 3D games, but Unity doesn't have a built-in 2D character controller. So for all of our collisions and things, physics and stuff, we're actually going to treat this more like a 3D game, but it doesn't really change very much. So we just got to make sure we're using the non-2D versions. Box collider here for our ground, and let's go back to our scene view. So once again, this green outline, if you have your gizmos turned on, will show the area of that. We do want to mark this. No, we want to actually keep this. Don't mark it as a trigger because we need to physically stand on this. However, we do want to adjust the position here. We want to change this to be lowered. So for example, let's set it to -1, and that kind of matches up with where the dinosaur is standing. In the game, the player does not stand on top of it here. They actually stand sort of below it there. So we adjust the collider to sort of match. We might need to make this a little bit more. In fact, we probably will, because the character controller has this like skin width property, which will kind of offset the collision a little bit. Let's keep it at -1 for now, and we'll just adjust it once we test it. Another really minor thing that's sort of a tangent, I probably should have did this before, but for these two objects, we want to make sure the player is always rendered on top of everything else, like our ground. So if we go to our sprite renderer, we can change the order of here on the player to 1. So you can notice like here, the ground is actually being rendered on top. So you're seeing that line go through him. So we just change the order of our player to 1, which will cause our player to always be rendered on top. And so yeah, now it looks like he's sort of standing on the ground plane here, even though it's just a 2D object. All right, so this looks good. Let's actually start writing a script for this, and we can tweak things as we need to. So I'm gonna create a folder for scripts just to keep my project organized. I'm gonna right click, create C# script. I'm gonna call this player. And we can click our player game object, and we can drag this script onto it in the empty space at the bottom here. And let's go ahead and edit this. All right. So I usually like to get rid of the kind of boilerplate code that Unity provides, just to kind of start fresh here. Now to move our player, we need to get a reference to that character controller component, because that's what we use to actually move the character. So let's declare a variable of character controller. I'm just going to call this, let's say, character. And then in the awake function, we can assign that reference. Awake is a function that Unity calls automatically when this script is initialized. Make sure you're capitalizing the A here. All of these are case sensitive, otherwise Unity will not call this function for you. We can assign this value by saying get component, and then specifying the type of component we want to get, which is character controller. So this is going to search the same game object that this script is on. So our script is on this game object. We're going to try to find a reference to another component on this same object, which in this case is the character controller, which we specified by the type here. All right, from here, let's add a variable for our direction. So the direction that the player is moving. This will be a vector3, and we'll just call this direction. Let's add a function on enable. So this is another built-in function Unity provides. It will get called anytime this script is enabled. So at some point we will disable the script when you get a game over to prevent you from being able to move or jump or anything. And whenever we re-enable the player, we want to reset the direction to 0. So we'll say direction equals vector3.0. Now from here, let's add our update function. This is a function Unity calls every single frame your game is running. This is typically where you will check for input. Now, we always, before we even check for input, the input we will check for is whether you jump or not. But no matter what, whether you're jumping or not, we need to apply gravity to the player. So let's actually add a custom variable for gravity. We could use Unity's, there is a built-in gravity variable we could use. But in this case, I actually want to just declare my own. Because one, the built-in variable is a vector3, and we only really care about gravity in the y-axis. And it's just cool. It just makes it a little bit easier to customize this. In theory, if your game had, multiple different things that are affected by gravity, having a variable would allow you to customize the gravity for each individual object. Maybe you want that, maybe you don't. But in this case, I'm just going to declare my own gravity variable. I'll set it to be 9.81, which is kind of the gravity of real life. Well, actually, so this is another reason why I don't want to use a rigid body, is because once again, rigid bodies are going to try to simulate realistic physics as much as possible. I actually want to increase the gravity a lot more to get it to feel the right way. The value, this gravity value here, I just feel like the dinosaur is up in the air too long, and it almost feels like they are floating too much. So I'm actually going to double this. I'm just going to times this by 2. And this, by the way, is just a default value. This will show up in the editor, and we can customize this however we want. So this is just serving as a default, but if you were to change it in the editor, the value that shows up in the editor is the actual value it'll take. All right, so in our direction, we're going to say plus equal vector3.down. We want to apply gravity going downwards times our gravity scalar here. And then gravity needs to be applied over time. So we're going to say time.delta time. That's how much time has elapsed since the last frame. Now, let's check if the character is grounded, and only if they are grounded will we check for their jump input. So this is where this is really easy to do, because our character controller has a is grounded property just built into it, which is really convenient. So if the character is grounded, we actually don't need to apply the gravity. So we can set the direction to just be down. So we still want to apply a force that pushes the player down. But the problem with this line of code is this gravity builds up over time. It keeps building up and building up and building up and building up, which we don't want. When the player is actually on the ground, we can just apply a constant force of down, but we don't want that value to continue to build up over time. So we'll kind of reset it to just be down. And then now finally we can check for input. So we can say if input.get button down, or actually maybe just get button. The difference here is get button will check every single frame that you're holding down the button, whereas get button down will only check for the single frame it was first pressed down. So if we use get button down, you're gonna have to repress, let's say spacebar every time. You have to press space over and over again, whereas with get button, you can hold it down, which from my testing feels a little bit better. It doesn't really matter, but I kind of preferred it allowing the user to hold it down if they want to. So if input get button jump, and so this is where Unity has built-in inputs. So if we go to our project settings, if you go to edit, I already have it on my menu bar, but if you go to edit project settings, there is built-in inputs already. So if you go to the input manager, Unity has a number of inputs already set up for you, including one called jump, which is mapped to the space bar. So you can of course remap those and change these settings, but whatever you specify should be here. You could also check for individual keys. Like you could say get key down, and then you could specify like, space bar or something like that. But in this case, I'll just use the axis value here, jump. And if we do jump, then I'm going to set our direction to be up times some jump force. So let's add a variable for jump force. And from some of the values I've tested, I found a value of 8 works pretty well. But once again, you can tweak this. This is just a default. So in the editor, you'll be able to customize this to your preference. Jump force. So vector3.up times our jump force. And finally, we just need to actually apply this direction to the character. So we're going to say character.move. We're going to move them in that direction. And we also want to move the character over time. So we're going to say direction times time.delta time. And that is it for our player script. That's our entire player script. Let's go ahead and test this. You can see once again our player script, we have those 2 variables showing up. So we can tweak these if we want. If we don't like these values, we can always customize them. Let's go ahead and run our game and see how this feels. So I can press spacebar and I can jump. Here we go. I can hold it down to keep jumping if I want. But this looks and feels good. Now the contact point on the ground, I feel like needs to be a little bit lower. So I actually am going to decrease this even further. So I'm going to say -1.1 maybe. Let's replay that. Yeah, that feels a little bit better. It's positioned more where I want. So there we go. That looks good. So next I want to start animating some of our objects, including our ground, so it actually looks like we're moving and we get that side scrolling effect. But also I want the speed of the game to increase over time. As you get further and further, it's going to get faster and faster. So we need some kind of variable that we can use to change our animation speeds dynamically. And so I'm going to create a game manager script that will manage some of our game state, including sort of our global game speed, which we're going to then use across several different objects in our game to make them all animate faster and faster as the game gets faster and faster. So let's go ahead and create a new script for game manager. And let's also create a new object in our hierarchy. So we can right click and let's just create an empty object. I'm going to reset the position, although it doesn't really matter. I'm going to call this game manager. I'm going to drag this to the top. Once again, it doesn't really matter, but just kind of like it being at the top there. And I'm going to add our script to this. Let's go ahead and edit this. So our game manager here will manage some of our kind of overall game state. You know, what's your score? You know, what's the game speed? It'll do some of our UI and things like that once we get to that. So this is a script that we need to access some of that game states through a lot of our other code. So we're going to turn this into a very, very simplified singleton, which is a design pattern commonly used in games, especially for something like a game manager. A lot of developers might overuse singletons and use them in places where they really shouldn't. But this is such a simple game that I think turning this into a very basic singleton will suffice and just simplify a number of things. So now this won't be like a true singleton, but I'll just kind of show you how we can do a very, very basic version of it. So the idea of a singleton is that you can access it from anywhere, and there's only a single instance of this class, which makes sense. There doesn't need to ever be more than one game manager. So we need to declare a static variable of the same type of our class here, and I'm going to call this instance. And this is going to have a public getter, but a private setter. So it's a public variable with a getter, but then it has a private setter. So only this class can manage the single instance, but anyone can access this from elsewhere. In the awake function, we can assign this instance, but we only want to assign the instance if it doesn't already exist. So if we check if instance equals null, then we'll go ahead and assign this instance to be this. This just referring to this instance of the game manager. Else, if there already is an instance and for whatever reason another one is being created, we're going to destroy that one immediately. Destroy immediate game object. So this is where that single instance comes in. We don't ever want there to be more than one. So if for whatever reason a second one is being created, we will destroy it immediately. And then on destroy is another built-in Unity function. We're going to check if this global instance is this, then we'll unassign it. Instance equals null. So this is a very, very simplified version of a singleton, but for our purposes, this totally suffices. And this will allow us to access this from anywhere else. So for example, just pick some random code here. I could say game manager.instance and then access, anything I need to. All right. So for now, I just want to focus on creating the properties we need to be able to animate our objects. So I'm going to create a variable for our game speed. And I'm going to also make this have a public getter with a private setter. And I'm also going to declare a separate variable called initial game speed. And maybe this defaults to 5. So this will be the game speed when the game first starts, but this value here will be the actual current game speed, which will increase over time. And along those lines, we can also specify how fast the game speed increases. So we can have a variable for, let's say, game speed increase. And maybe this increases by 0.1 per second. All right, so from here, let's get just a little bit of structure for kind of starting a new game. And then we'll revisit our game manager further in the tutorial once we start doing the rest of our game state and game over and things like that. But let's implement the start function, which Unity is a built-in Unity function. It will get called the very first frame this script is running. And from here, we can actually at first, let's create a new function called new game. And in our start function, we'll say new game. All right, so in new game, we can set our game speed to be equal to the initial game speed. And then in our update function, we will increase the game speed. Say plus equals that game speed increase times time.delta time. So that's all we'll do for now. There's definitely going to be a lot more we're going to do in this script. But for now, we're setting our game speed to be some initial value, and then that game speed will increase over time by however much we specify in this variable. So just to show you that real quick, let's play our game. And I'm going to switch to, let's unmaximize this. I'm going to switch to the debug mode here. And you can see our current game speed. So it's increasing as the game continues on. And so 5, 6 is still going to be quite slow. But then, if you haven't died and it's been a minute, it's going to be a lot faster. So it's going to get harder and harder and harder, which I think makes the gameplay more interesting. Okay, so now that we have our game speed set up, we can start animating some of our objects. So let's start with our ground, because that's going to create that side-scrolling effect that's really important. Let's go ahead and create a new script for our ground. I'll just call this ground. And just like everything else, I will assign this script to our object. Let me switch back to the non-debug mode. Let's assign our ground script there. And let's go ahead and open this up. Now, to animate our ground, what we need to do is essentially, we don't actually want to change the position, because at some point it ends. So what we want to do is that we actually want to change the tiling on the texture, on the sort of sprite texture. Because if you remember earlier, we changed our ground sprite to be repeatable. So if we sort of tile it, it'll tile infinitely without us even having to change the position. So that's what, I changed the wrong thing. Set this back to 0. Now the problem is the sprite render does not allow us to change the texture tiling values. Like on the material here, you'll see these tiling values, but we can't actually change these, unfortunately. So we don't want to use a sprite renderer for this object. Instead, we're going to change this to use a mesh renderer, which is once again technically more of a 3D object, but we can totally use it for this just the same. So I'm actually going to remove the sprite renderer. Instead, I'm going to add a mesh renderer. Actually, we need first, let's add a mesh filter and then a mesh renderer. I'm going to bring these both to the top, although it doesn't matter the order here, but just like them to be there. The mesh filter defines the mesh that's being rendered. So it's sort of the raw data, the raw geometry that is being rendered. We're just going to render a quad. So there's, 3D objects like a cube, a sphere, but we just want a quad, which is just, a 2D, just a 2D thing. So here we get this little square. It's that magenta color because there's no material sign. That's just kind of the default like shader color, I suppose. All right, so that looks good. We do need to create a new material to assign to this. So let's go ahead and create a folder for materials. And inside this folder, we can create a material. So let's do material. I'm going to call this our ground. And we're going to change the shader to a unlit transparent. Our ground sprite is actually transparent. So that's why we're using transparent. Otherwise, we could just use the, unlit texture. But in this case, it has some transparency to it. So we want to make sure we keep that. We can drag our ground sprite into there. And let's reassign this to now that we have our material, we can drag this material just into the empty space here, and that will add it. Or now we can actually see that. Now, of course, the scale of this is not right at all. So we want to change this. We actually want to change the scale to bring it back to the size it should be here. So with my sprite, a scale in the x-axis of 25 is what we want. And I believe the reason for that, let me do some calculation here. So if our sprite is 96 pixels per unit times 25, that's 2400 pixels, which, if we look at the size of our sprite, is 2400 pixels. So in other words, what I did is I take the width of it, 2400, and I divide that by the pixels per unit I set. So that's 96, and that gives us our scale of 25. And then in the y-axis, it's 96, so that's just 1. 96 divided by 96 is 1. So if you're using a custom sprite, that's how you could calculate these values to get the scale back to how it should be. Now, with that change, the collider also needs to get reset because you can see it's way bigger than it should be. I guess it doesn't really matter, but I'm going to reset this as well. I'll just literally reset it, and that's going to automatically kind of reconform it to the object. And I guess this can be 1, but the Y we can reposition down again. This will just be the same, -1.1, and that looks good. All right, so we reset up our ground sort of technically as a 3D object, set the scale to 25, but now that we have this material, we can tile this. Or really, we're going to offset it. And you can see as I change the offset, it's sort of animating the ground, and this goes on infinitely. This will never end. This value can increase forever, and our ground will continue to tile. So that's why we went through that entire process. So now in our actual ground script, all we need to do is add, 5 lines of code or so to change that offset property. Let's get rid of some of the boilerplate. I'm gonna add or get a reference to our mesh renderer, which is one of those components we added. Just like we did in our player script, I'll assign this using get component in our awake function. Then in our update function, we can update this. So mesh renderer.material.main texture offset, and we're going to increase this by some amount. So we want to animate it to the right. Well, it actually might seem like it should be animated to the left, but if you take a look, if we look at our ground here, if I change this offset to be to the right, it actually animates to the left. So we actually want to increase this number when I'm change that number to the right to animate it as if it's moving to the left. So we're going to say vector2.right times some speed variable, which we haven't declared yet, times time.delta time. Now for the speed variable, this is where we will use our game speed here. But it's not just directly the game speed. We actually want to take that game speed and divide that by the scale of the object, our 25 here. So we can say game speed or game manager.instance.game speed divided by whatever our scale is in the x-axis. So transform.localscale.x. Cool. So that's the speed at which our ground will actually animate. Let's go ahead and test this out. So there is our ground being animated. So now it actually feels like the character is actually moving. And once again, this is going to animate faster and faster as our game speed increases. So why don't I bump up our game speed, increase even more. Let's just keep making this faster. Yeah, so now it's getting faster and faster. So that's why we had to go through this entire process to do all this game speed stuff, because it allows everything in our game to be animated based on that game speed. We didn't have to do that. We could just have our entire game be the same speed the entire time, but that's kind of boring, and I feel like it doesn't make the gameplay very interesting. So having this speed get faster and faster just makes it more fun, in my opinion. So there's a little bit of a process to get that working, but now that that's all set up, it's easy. And for some of our other objects, it'll be even easier. All right, next let's animate our dinosaur. This will be animated differently because we really just need to swap out the sprites over time. So we have a few different sprites here. We have the idle one and then the run. We have run 1 and run 2. So we just need to cycle between those two run sprites to get the dinosaur to be animated. That's also what we'll do for our bird, for example. So we can write one script that we can reuse for both our dinosaur and our bird once we eventually set that up. So let's create a new C# script. I'm just going to call this animated sprite. Open this up. I'm going to delete the boilerplate here. Now we need to provide an array of sprites that we're going to cycle between. So let's declare an array of sprites. Brackets here indicate that this should be an array. We also need to get a reference to the sprite renderer so we can change the current sprite. So let's get sprite renderer here. I'll just call it sprite renderer. And we can assign this in our awake function, just like we have for other things. Sprite renderer equals get component sprite renderer. Now we also need to keep track of what frame or what sprite we're currently showing, what index in the array. So I'm gonna call this frame. It's just gonna be an integer as the index of the array. All right, and finally we need to actually animate this. So when this script is enabled, so on enable, we're going to invoke a function, and this will be a let's create a function called animate, and we're going to invoke this function. Now when you invoke, you have to invoke by the name of the method. So we'll say name of animate, and then we need to specify a time here. Our time should be, well, so actually, let me revisit that line of code. Let's start with our animate function. Then it'll make a little bit more sense. Whenever we animate our sprite, we need to increase the current frame. We need to check if the current frame is past our array. Like if we're beyond the length of our array, then we need to cycle back to the beginning. So we can say if frame is greater than or equal to sprites.length, then we start back again at the first one, 0. Things start at 0, not 1. And then from here, as long as our frame is, well, let's just start by doing this. Sprite render.sprite equals sprites and then whatever frame we're on. Now, as a safety check, we can make sure that this index here is in bounds to our array. this will prevent you from hitting an index out of bounds error that I've had a lot of people on Discord ask about. And the only reason that you could possibly get that error in this scenario is if you forget to add sprites to your array. So if this is empty, then even with an index of 0, it's always gonna still be out of bounds. So either don't forget to assign sprites to this, or just in case, honestly, just because I get tired of people asking me about it, let's add a safety check to make sure that our frame is greater than or equal to 0 and less than our sprite.length. This will guarantee we will never get an index out of bounds error. Now, sometimes getting an error is actually helpful because it lets you know that you made a mistake. It would let you know, hey, you forgot to, add sprites to your array. Therefore, it's, you got an error for that. And that's actually sometimes good as a developer to be informed of those issues. Now, you don't want those errors to cause problems for the actual users, because that will actually crash their game. So anyways, that's good. That's all we do for our animate function. So we're just basically cycling this index through our array and updating the sprite accordingly. Now we need to recall this over and over and over again. So once animate gets called, we're going to invoke animate again every, let's say every 1 second. But we don't want to do every 1 second. We want to do based on the speed of our game. So just like we did for our ground, we want to use this game speed variable. So we're going to say 1 second divided by whatever our game speed is. So as our game speed increases, it's going to shorten the amount of time between animation cycles, which is going to make our animation faster. It's going to make it look like the dinosaur is moving faster and faster as our game speed increases. So if we don't do this, if we don't factor in our game speed, well, then it's just going to make it it's just going to make it feel weird, because the how quickly the dinosaur is animating is not going to match up with how quickly the ground is moving. So we want to factor this variable into everything we use. That way it's all synced up and looks and feels the right way. Now let's revisit this line of code here. So same thing, we want to kick off our animation by invoking this, but we want this to happen sort of right away. I could literally just call the function. The problem with this is has to do with Unity's lifecycle. Our game speed doesn't get assigned until new game is called, which is called in start. Start will always be called after on enable. So that means so this would get called first. It'll call animate, which will then kick off our animation. That's fine, but then it's going to tell it to animate again, let's say a second from now. But our game speed is 0. So you're going to get a divide by 0 error, which is no good. That's going to cause a problem. So we want to actually invoke our animate function after some amount of time. That way this can get executed first. And if you actually provide a value of 0, it will get called the next frame. It won't get called immediately. It'll get called the very next frame, which gives us enough time to get called and then for our game speed to get set. So it's kind of a trick in a way. It's almost kind of like a hack, but it does the job. You could just make this like, okay, don't start animating for like a second. But that's kind of arbitrary, and then your character is just sitting there not moving for a second, which we don't want. You could also just make this some really small number, but yeah, a value of 0, just make sure it doesn't start until the next frame, which is basically what we want. We could do this on start as well, but the problem is we're going to be enabling and disabling our player when you get a game over and when you restart. So start will only ever get called one time for the entire life cycle of that object. So we need to do this on enable. That way it restarts animating whenever the dinosaur is re-enabled after a game over or when you start playing again. So anyways, that's that. This script we'll be able to reuse for multiple objects, for our birds, for dinosaur. If you had any other animated objects, we can go ahead and drag this onto our player. Let's make sure we actually assign the sprites to this. Let's add our Dino Run 1 and Dino Run 2, and let's play this. All right, so there we go. So now he's doing his little run. And once again, if we increase our game speed, this is going to get faster and faster as well to match how quickly the ground is moving. So perfect. Real quick before we move on, we do need to do one more thing in our animated sprite, which is when our sprite is, or when this script is disabled, we need to cancel the animation. So we can add on disable, and all we need to say is cancel invoke. So that will make sure that it stops animating when this script is disabled, which once again, when we, in our game manager, when you get a game over, we're going to disable everything, and then it'll get re-enabled once you start playing again. So that's an important function. Otherwise, the animation will always continue. So now let's start working on spawning our obstacles, our birds and our cactuses. But first we need to create prefabs for all of these so we can then spawn them dynamically. Prefab is a prefabricated game object. It's essentially a game object that you've turned into an asset that you can then reuse throughout your entire project, instead of just the single scene that you created it in. So let's start with our bird, for example. Let's drag our bird sprite into our hierarchy, creates a new game object. I'm going to rename this to bird. Oops, to bird. Let's reset the transform. Mine's already reset, but make sure you reset these transforms back to their just starting values as 0 or scale is 1. We do want to add a box collider to this so we can detect collision between the bird and the dinosaur. So just a regular box collider, not the 2D one, because once again, we're technically using sort of 3D components for some of these things. So a character controller, which is what we need to detect collision against, does not detect collision against the 2D versions of these, because it's a different system entirely. So normal box collider, we do want to mark it as a trigger. We don't actually need to physically collide with these things. We just need to detect when you've touched the object. We can also add our animated sprite script that we just finished making, just for our bird here, since the bird is animated. So we can add in our 2 sprites there. Now in our code later, we need to detect which object or what type of object you've collided with, because the player could collide with other things like the ground. We only want to detect when they've collided with an obstacle. So what we can do is we can set a tag on these objects to know which kind of object you've collided with. Let's add a new one, call this obstacle, or call it whatever you'd like. And let's go back to our bird and assign that tag. And then for the same reason we did for our player, I want to make sure I set the order and layer here to be increased so it draws on top of the ground, not being past it, which wouldn't make sense. And so that's it for now for our bird in this case. We can now turn this into a prefab. Let's create a folder called prefabs. And all I need to do is drag this into our folder. And so now it's a prefab. We can reuse this asset across our entire project. And I can actually delete it from our scene. Although actually, I want to update a couple things, but let me show you how we could update our prefabs later. So I've deleted it from the scene, but I still have the asset here. So I can always reopen this up and it'll kind of create sort of an instance scene that we can edit this in. I actually want to adjust the collider here. You see there's a lot of empty space at the top, and that's because of how it animates. I've sort of made the sprite a little bit bigger than it needs to be. That way, when you switch between the 2 sprites, it stays lined up accordingly. And so it's basically a 96 by 96 pixel image, which keeps the unit exactly at 1. But our sprite is a little bit larger than it needs to be, so we can potentially adjust that to be a little bit more accurate. If we change our sprite size to be 0.833 repeating, and then we also offset that by negative 0.083 repeating, it's going to line up the very top of, so in our bird 2, the very top pixels to the top of our collider, and for bird 1, the very bottom of our of the pixel to the bottom of the collider. So you don't need to do this, it's not required by any means, but it just makes the collider a little bit more precise based on the sprites for our bird here. All right, so that's our bird. We basically need to repeat the same process for all of our cactuses as well. All right, so for our cactuses, let's kind of do the same thing. Let's start with each of these. And let's add our box collider, mark it as a trigger. I marked our bird as a trigger, right? Yeah, our bird's a trigger too. Okay, just had to double check in case I forgot. It's really important. So mark it as a trigger. Let's tag it as an obstacle. And we don't need to add any other components to this because it's not animated or anything. Let's set the order and layer to 1 so it goes on top of the ground. And that looks good. Maybe what I should do is just set our... Oh, no, we can't because this is a different kind. Never mind. So yeah, set the order to 1. That looks good. The collider lines up perfectly in this case, so we don't need to do anything else. So this one, I think we can just drag into our prefabs folder, and that one's good to go. Let's do our single cactus, box collider, trigger, obstacle. Drag it into our folder. Good to go. All right. Cactus large triple. Oh, I forgot to set the order. Order 1. All right, this one, order 1, box collider, trigger, obstacle. Good to go. It lines up. Drag this into our folder. Okay, now for these ones you'll see once again that there's a lot of empty space at the top. That's the reason for this is so when you drag these into the project, they will all be lined up. They'll all be lined up at the same spot on the ground, regardless of their height. But that means when we add our box collider, it's gonna, there's gonna be all this extra space again. So we can adjust these as well, just like we did for our bird. So let me just check what these values should be. So in this case, 7291667. It doesn't have to be perfect, but yeah. Negative 0.1354167 lines it up perfectly. This was based on some math. Like these aren't just random values. There's math. I did some math to figure out what the exact size of the box collider should be based on how many pixels this takes up. I honestly don't remember how I did that math, but once again, it doesn't really matter. Feel free to just adjust this till it lines up close enough. It doesn't really matter. Okay, so we have our box collider, trigger, size, obstacle, order layer 1. That one's good to go. Let's drag that in. Let's do the single one. Order layer 1, box collider, trigger, obstacle. Now, once you've figured out what these values should be, they should all be the same for these. Because they're all the exact same height. So there we go. Order layer 1, box collider, trigger, obstacle, good. Drag that in. Now this is a little bit tedious, but sometimes that's just part of game development. Oops, I didn't mean to do that. All right, the last one. I think this is the last one. Box collider, trigger, order 1, obstacle, and then the colliders. What should these values be? That's and that. There we go. Lines up. Good to go. Let's drag this in. All right, is that all? We have our 6 different cactus variants. We've got small ones and tall ones, and then we've got single, double, triple, single, double, triple. So there we go. Those are all of our prefabs. They're all obstacles. They're all order layer 1. They're all triggers. I think our our prefabs are all set up and good to go now. All right, now that we have our prefabs created, let's start writing our spawner script. Create a new script called spawner. Let's go ahead and open this up. I'm going to delete the boilerplate here. So for our spawning script, we need to provide which objects we want to spawn. So we need to get a reference to those prefabs. Now in our case, we're going to use the single spawner script to spawn all of our different objects. So we're going to provide an array of prefabs that we can spawn. But I also want to provide a way to give them a spawn chance. So for each one of the different objects, we can set how frequently that object will spawn. And that's important because we want some of the easier objects to spawn more frequently. So for example, we'll get like the single trees will spawn more commonly than the double. The double will spawn more commonly than the triple. That way it kind of balances out the difficulty of the game in some ways. And obviously you can tweak those values and determine how much you want them to spawn. But in order to do that, we need to be able to associate a prefab with a spawn chance as well. So let's create a custom data structure so we can kind of identify one of those. I'm going to declare a public struct here. I'm going to call this a spawnable object. And inside here, let's get a reference to a game object, which is going to be the prefab that we instantiate. And let's also declare a spawn chance float here. Now this spawn chance needs to be a value between 0 and 1. And we can actually do that in Unity. We can add a range attribute to our property or to our variable here and set that between 0 and 1. It's actually going to turn this into a slider in the editor, which you'll see in a moment. Now we can actually declare an array of these spawnable objects. Now the problem is these aren't going to show up yet in our editor, and I'll explain why. Although we actually need to create a spawner game object, so let's call this spawner. I'm going to reset the position. Let's drag our script onto it. And let's position this on towards the right where it will be off screen. So let's say it has a position of 8. So it's going to be beyond the edge of our camera. So objects will spawn off screen and then they'll get animated to move on screen. But you see here in our spawner script, that variable we added isn't showing up. And that's because it doesn't know how to serialize this data into something the editor can read and understand. All we need to do is add an attribute to our struct, system.serializable, and now it'll show up in our editor. So now we have our objects here and we can add new ones. So was there like 7 or 8 different objects? There's 7 different ones. So for each of these, we can assign the prefab. So let's start with our cactus small. Then we'll do our cactus. Well, so let's think about the order here will actually be important. So in our code, once we finish writing the rest of our code, it's going to loop through this array. So we're gonna pick a random number between 0 and 1, and it's gonna loop through the array. And if that random number is less than the spawn chance, it'll spawn that one. And if it's not, then it's gonna move on to the next one. And it's gonna check that one, then it'll move on to the next one, move on to the next one, etc. So the order here is actually important. Really, we just want to order these based on which is most likely to spawn, and then at the bottom will be the least likely to spawn. So actually we want the small cactus to be kind of the most common one, then maybe followed by the large single. So small single and large single. Then we can do doubles. So we start with a small double, then we'll do a large double. And then we can do the triples, the small triple, followed by the large triple. And then the bird will be last. Now, obviously, you can customize this, so feel free to adjust this to your preference. But now let's specify these spawn chances. Ideally, you would want these to add up to 1. It doesn't have to necessarily. In fact, if it doesn't add up to 1, then there's a chance that it'll spawn nothing, which is actually completely valid. In some ways it's helpful to the player because it will add, if it spawns nothing, then there's going to be a bigger gap between the different objects, which maybe gives the player room to breathe a little bit. So maybe that's, maybe we don't perfectly add up all these numbers to 1. So some of the values I've played around with are just 0.2 for this. That's 20% chance of spawning that. And then I just decrease this by 2% every time. So 0.18, 0.16, 0.14, 0.12. So on is 10%. And then this one I'll do 5%. So there's only a 5% chance that a bird will spawn. I think all these add up to around 95% or something like that. Somewhere in the 90s. So there's also a small chance that nothing will spawn as well. So once again, feel free to customize this to your preferences, but you know, it's going to pick a random number between 0 and 1. It's then going to loop through this in order. If that random number is less than this, then it will spawn it. Otherwise, it will then check the next one and then check the next one and so on. And then every time it goes to the next one, it's going to decrease that random number. So it'll actually eventually hit the threshold of one of them. All right, so back to our spawner script here. Let's add some variables to indicate how often we want an object to spawn. So we can add maybe this will be random as well. So maybe we can specify a range, like a min and a max range. So we say maybe the min spawn rate is 1 second and then the max spawn rate is 2 seconds. So that means it's going to spawn an object randomly between 1 and 2 seconds. And it'll be different every time. If you don't want it to be random, you just would, in the editor, just set these to be the same value. Yeah, so if you want it to be a constant, it's always going to spawn a new object at every 1 second, then you can just set them to be the same. All right, so from here, we actually want to start spawning our objects. So on enable, when our script is enabled, we will invoke our spawn function, which we don't have yet. So let's create that. I have a spawn here. We will invoke this. Gotta specify the name there. And then we need to provide the time. So this will be a random number between these two values. So we can say random dot-range between the min spawn rate and the max spawn rate. Now on disable, we want to cancel our invoke so it stops spawning things. So we can just say cancel invoke. And then finally in our actual spawn function here, like I said before, we're going to pick a random number between 0 and 1. So let's say the spawn chance here is going to be random.value. This is just a built-in property Unity provides to get a random float between 0 and 1. And then, like I said, we're going to loop through each of our objects. So for each of our object and objects, or actually we can't use that because it's a keyword, so we'll just say obj. For each obj and objects, if the spawn chance is less than the object spawn chance, then we will go ahead and spawn that. So to spawn it, we will say instantiate obj.prefab. That creates a copy of the prefab. Let's store this into a variable. We'll call it obstacle maybe. And then we're going to set the position of our obstacle to be offset by wherever the spawner is positioned. So we're offsetting the position based on the spawner's position. So in other words, it's essentially going to spawn the objects wherever you position the spawner in your scene. Now, I don't want to just directly assign the position to be equal to the... I don't want to do this. I don't want to just say equals transform that position. And the reason for that is because then it allows us to maybe customize their initial sort of position through the prefab. Specifically, for example, for our bird, if we do spawn a bird, the position is 0, then it gets offset by wherever our spawner is, so it would end up getting offset to there. So that's where it's going to spawn. Maybe for the bird, we want it to be up in the air a little bit. right? So what we can do is we can change the y value here to be, you know, maybe 0.5, maybe 0.25, something like that. And now it's going to spawn this in our scene at 0.5. It's going to offset it by our spawn position, which is 8. So now it spawns at 8, 0.5. So that just allows us to kind of control this better. So in theory, you could actually have different duplicates. Like we could have multiple birds and maybe one bird spawns at one height and another bird spawns at another height. You could do that if you wanted to. I'm just going to kind of stick with the simplified approach, but if you do that, just make sure you add another object here to your array and maybe tweak some of the spawn chances accordingly. All right, so back to our spawner script. Let's finish this up. Once it matches the spawn chance, or once it succeeds in spawning that object, we don't want to spawn another one. So we want to break out of this loop. The break here will cancel this loop, or we'll break out of it. If it doesn't meet the spawn chance, then we need to decrease this by however much this is here. obj.spawn chance minus equals obj.spawn chance. So the reason for that is, let's say we pick a random number, and let's say the random number is 0.5. Well, 0.5 is not less than 0.2, so it will then move on to the next one. Well, 0.5 is still not less than 0.18, so it'll move on to the next one. Well, 0.5 is still not less than that, right? So it's never going to be, if it's not less than the first one, it's not going to be less than any of the others. What we want to do is say, okay, well, first it's 0.5. It didn't hit that threshold, so we subtract 0.2. Okay, does 0.3 hit this threshold? Nope, it doesn't hit that threshold, so we subtract 0.18. Now it's 0.12. Okay, yeah, that does indeed hit this threshold. So this is less than the threshold, so it will end up spawning this third one here. Let's say the random value is 1, and we go through the same loop. So the first one, it tries, you know, it's not less than 0.2, so we subtract that. Next one, nope, it's not less than 0.18, so we subtract that. The last one, it's not less than 0.16, so we subtract. This one's not less than 0.14. It's not less than 0.12. It's not less than 0.1. So finally, it's 0.1. It's not less than 0.5 either. And so that's where, at this point, it didn't match any of them, so it would spawn nothing. So yeah, based on the math there, with these numbers, there's a 5% chance that it'll spawn nothing, which once again is perfectly valid, and actually like the fact that sometimes it doesn't spawn something. It kind of breaks up how much space there is between objects. All right, so I think there's just one more line of code we need to add to our script here, which is once it spawns an object, we need to have it spawn another object at another random interval. So we're going to invoke our spawn function again, this time picking a new random value between our min and our max. Great. All right, let's go ahead and test this out. Now we haven't animated these objects to move, so you can see they're spawning, they're showing up here in my editor, but they're not animated to actually move, you know, to the side. So that's our next step. Let's go ahead and create our script to animate the actual obstacles from right to left. So let's create a C# script here called obstacle. And we need to add this script to all of those prefabs we had created. So I'm going to select all of these. I'm going to go to our scripts folder here. I'm going to drag that onto it. Let's go ahead and edit this. All right, so for our obstacle, we just need to animate it or change its position over time to move to the left. And then eventually once it's off the screen, once it moves past the screen, we can just get rid of it. At that point, we don't need it anymore. So let's add our update function here. And in update, we're going to change its position, transform that position plus equals vector3.left times our game speed. So once again, if our game speed's up, the ground moves faster. We also want these objects to move, or these obstacles to move faster to match the speed of everything else. So So we're going to say it's going to move to the left times our game speed, or not game object, game speed, times time.delta time, because this animation happens over time. Then we need a check to see if it's past the edge of the screen. And if it is, then we can just destroy it. Now, the edge of the screen, you know, might change based on screen size and things like that. So we don't know like the exact world position of where that will be. So something we can do is calculate it. And let's create a variable to store what that value will be. So I'm going to create a variable called left edge. And in our start function, we'll calculate what that should be. So left edge will equal, we need to make a conversion from screen space to world space. And you do this by accessing the camera and calling a function on it. To access our camera, we could say camera.main. This will return a reference to the camera that's tagged main camera. So make sure your camera is tagged main camera. It should already be tagged that by default, but just in case, make sure it is tagged that. All right, so camera.main, and then there's a function screen to world point. So this is converting screen space to world space. Now the left edge of our screen in screen space is 0. And the right edge would be, you know, whatever the resolution of your screen is. So maybe the right edge is, let's say 1920. The left edge is 0. So we can actually just pass vector 3.0 here. That's good to go. So that converts, that is converting our screen space coordinate to a world space. And we only care about the x-axis. So I say .x. And that's really it. Although we do want to offset this a little bit more, because if I take, let me just take one of these objects here. So let's say, you know, the left edge is here. Well, as soon as this crosses, boom, it's crossed, it's going to get destroyed. But, well, it's not technically off the screen yet. I need to wait for it to be fully off the screen. So what we can do is just offset that position by 1 unit. So we can just subtract an additional unit on top of that to make sure it gives enough space for the object to fully pass the screen before it gets destroyed. Maybe you can even do 2 units in case some of your objects might be a little bit larger. In fact, I think, yeah, like for example, this one is larger than 1 unit. So we need to make sure it's large enough that any object will go fully past the screen before it gets destroyed. It's kind of arbitrary. Now we could do some more math to make that more dynamic, but it's really not necessary. So, but now here we can just check if our transform position.x is less than the left edge, then we destroy the game object. It'll just get destroyed. All right. And this is really just so, like, you know, once an object past the edge of the screen, like there's no point of it existing anymore. It's just gonna continue to consume resources that it doesn't need to, so we can just destroy it. If you want, you can take a more advanced approach to this, which is to use object pooling. So instead of destroying and reinstantiating objects, you reuse them, you recycle them over and over again. We, in my opinion, really don't need to do that. This is such a simple game that I'm not at all concerned about performance, but maybe if you're building for mobile, you know, maybe you might want to do something like that, in which case I would encourage you to research that and look up how you can implement object pooling in your game. But anyways, I think that's it for our objects. Let's go ahead and test this out. They should be animated now, moving to the left, and then we should see them disappear when they go off the screen. There's a cactus. Yeah, so this looks great. Now, of course, there's no collision yet on our objects because we've marked these as, there are colliders, but we've marked them as triggers. So it doesn't physically stop the dinosaur from hitting them. But yeah, this is working. You can see they're kind of getting deleted from the scene too once they pass the screen. Yeah, so once they kind of get far enough past the screen, they get destroyed. And so this is what a side scroller really is. The dinosaur is technically just staying still, and the rest of these objects are what are moving. It's the environment that actually moves around you to make it feel like the player is actually moving. And our ground in this case is technically stationary as well. You can see the transformer is not changing at all because we use the technique to just tile it over and over and over again. So it makes it feel like it's infinite when it's really not. And our game's getting faster and faster. Now you'll notice here the obstacles on the ground move at the exact same pace or rates that the ground is moving. Just as an example, let's say I didn't factor in the game time here. Let's see what this looks like now. Well, one, they're going to be really slow, which is fine, but you'll notice that they just don't, it just doesn't line up. The ground and these just don't move at the same rate, so it just looks really weird. So that's why that's really important that we factor this game speed into all of our objects. Okay, let's go ahead and detect collision between our obstacles and the player, so then we can trigger a game over. So let's actually open up our player scripts. This is where we're going to actually detect collision. We can add a function called onTriggerEnter, and then this takes in a other collider that we have collided with. So once again, make sure you have tagged or marked all of your colliders on your obstacles as triggers. Triggers should be checked on, and make sure they're all tagged as obstacles as well. It's going to become both important in this code. So on trigger enter, we need to verify that the other thing we're colliding with is an obstacle. So we can say if other.compare tag to obstacle, then we know that it is that type of object. This needs to match exactly to what the string is in the tag. They need to be, exactly the same, case sensitive, make sure there's no extra spaces or anything. And if this is the case, then we can trigger a game over, which the game over will handle in our game manager. Let's go ahead and go to our game manager. Let's add a game over function. I'm marking this as public because we need to be able to call it from our other script. So say game over. Now on game over, what should we do? Let's set our game speed to 0. Let's disable our game manager. That way it doesn't increase the game speed. When your script is enabled, the update will not get called. So we don't want our game speed to start increasing again. What else? We need to deactivate our player and our spawner. So to do that, we need to get references to those two objects. So let's go ahead and create some variables for our player and for our spawner. And in our start function, at the top of our start function, we want to say player equals find object of type player and spawner equals find object of type spawner. And then in our game over, we can say player.gameObject set active to false, and same thing for this spawner. Spawner.gameObject set active false. We should also, oh yeah, no, actually that's good. What else? We're gonna do some other stuff, like we'll show the UI, we'll update Hiscores, but we're gonna handle those separately. So for now, I think this is good. We should maybe build out the rest of our new game as well. So these two kind of are almost opposites of one another. So here we reset our game speed, we re-enable the script, and then instead of setting these to not be active, we want to set them to be true, active true. Also, whenever you start a new game, we should clean up all of the objects in the scene. All the obstacles need to get removed so you start fresh. So to do that, we can say obstacle, let's declare an array of obstacles here. And we say find objects of type plural. So make sure this is objects plural, not singular. Find objects of type. For each obstacle in our array, we will destroy it. We destroy obstacle.gameObject. Make sure you don't just say destroy obstacle. That will only remove the obstacle script from the game object, but it won't destroy the rest of the game object. We need to destroy the entire thing, which includes the sprite renderer, the collider, the script, and so on. We need to destroy the entire thing. Cool, so that's good. That's clearing all the existing obstacles, so you start fresh. We kind of re-trigger our game state to be at the beginning. We reactivate our objects. I think that's it for now. Now we just need to call this from our player script. So if we collide with an obstacle, we're going to say game manager instance.game over. Let's test this out. We won't really be able to test the new game yet until we add some UI, but we'll do that next. I can jump over these to avoid getting hits. But if I don't jump over them, then I do get hit. And the player goes away, everything freezes and stops, and we're good. And then we'll display some UI, and once you click the restart button, it'll restart again. Okay, let's create the UI for our game. I do want to import a font that we'll use that'll kind of match the pixelated style here. So if you downloaded the project earlier to get all the sprites, it'll also have a font you can use. You can, of course, use your own font. You can find a font somewhere online, use that. But there will be a font included. Specifically, you want this TTF file. So public pixels, the name of the font, .ttf. So I already should have that set up. Or not set up, downloaded from earlier. So let me just drag this in. Public pixel.ttf. I'm going to put this into a fonts folder. Let's move that in there. All right, so for our UI, we need to create a canvas in our hierarchy. So right click UI canvas. And then in this, we're going to right click our canvas and we're going to create some text elements. So I'm going to use text. Now, in newer versions of Unity, we typically use Text Mesh Pro, which is it's an extra package that is installed in Unity. If you open the text or open your package manager, you should be able to see that here. I believe it comes installed by default in newer versions of Unity. So that's what I would recommend. You can also use the legacy components too, which actually in every one of my other tutorials, that's what I've used. But now that I'm using a newer version of Unity, this is more of the default. So anyways, use a text component, whichever one. If this is the first time using Text Mesh Pro, it might need you to import some stuff. So let's go ahead and do that. Yeah, this will create a new folder in your project. You can close this now. And we need to turn this font into a Text Mesh Pro asset as well. So I think if you right click your font, go to create, and then in here somewhere, there's so many options. Oh yeah, Text Mesh Pro, and then do font asset. This will convert it to an asset that we can use on our text component. So on this component, let's drag in our asset there. That uses the new font. I'm going to center this. I'm going to middle align it. I'm going to disable word wrapping. Let me check my other project to kind of get some of the settings I want here. I'm going to increase the font size. And once again, none of this is has to be this way. Feel free to customize this to your preference. What else? I'm going to make this always capitalized so that this will always uppercase everything. Let's set this to be game over. I'm going to change the color to be sort of a grayer color. It's the same color as the dinosaur, so you can use the color picker and just pick the dinosaur's color or set it to be whatever you want. I'm also going to increase the character spacing here. I'm going to make it the same as the font size. So this is trying to match the original game as closely as possible. It's not exact, but that's good enough. All right, so this is our game over text. I'm going to rename this to game over. And we also need a button, like a retry button. So I'm going to right click our canvas again. I'm going to go to UI button, Text Mesh Pro. Once again, you could use the legacy ones too. For our button here, let's go ahead and we actually, yeah, so this has an image on it, which we have a sprite for. So there's a retry sprite, so I'll set that. Now it doesn't, it's all stretched weird. So let's click the set native size button. And then usually buttons have a text component as like a child. So we don't need that. We can actually just delete that. And from here, it's just really a matter of sort of just kind of repositioning these. So maybe I might want to move our text up a little bit more. I'll set this to like 72, for example. Maybe our button will get lowered. I also feel like the button's maybe a little bit small, so I can always scale this. Maybe I scale it by, 2.5 or something. I might want to lower this as well. Let's do -48. That feels pretty good to me. Cool. What else? I think that's really it, actually. Now all we need to do is we need to hook up this button to call our new game on our game manager. So the way we do that is there's an on click here on the button component. We can click the plus button and we can drag in our game manager here, and then we can call any function we want on that script. Now the problem is it doesn't show up here because it's not a public function. So let's go to our game manager script and let's change this to be public. New game. Also, I'm going to rename this button to retry. Call it whatever you want. So once again, we drag our game manager object to here. Do not drag the script onto there. I've had people do this and not understand why why nothing showed up. Drag the object from your hierarchy in there. And then now we can click new game. Sweet. Now I think the only other thing we need to do is in our game manager, we need to get references to these UI components so we can turn them on and off respectively in new game and in game over. Now these ones we can't just assign automatically because there's not a way to distinguish them from one another. So we need to make these public references, and we have to import. If you're using Text Mesh Pro, you have to import TM Pro. If you're using the other kind of legacy ones, you have to, I believe, import using Unity Engine.ui. Otherwise, TM Pro here. And for Text Mesh Pro, this will be Text Mesh Pro U GUI, and we'll call this the game over text. And then for the button, so actually we still need to import using Unity Engine.ui because the button component is still a Unity UI class. So retry button. All right, so on new game, we're gonna set those off, and on game over we're gonna just turn them on. Sweet. So let's go ahead and test this out. So initially when I play the game, they should actually disappear because by default the game just starts automatically. We gotta make sure we assign these, so otherwise we'll get errors. In fact, I'll just show you what will happen. We'll get some null reference exceptions because we haven't assigned those. We're trying to access a null object. So let's drag these references into their respective slots and try again. So once again, they disappear immediately. You can see they're turned off here in the editor. I die, we get a game over, and I should be able to click this, and there we go, it restarts. So that's kind of our full game over retry with some UI in there. Okay, to tie everything together and to kind of wrap up, let's do scoring, which will also include some UI as well. So let's go ahead and create a couple more UI components in our canvas. Let's create some more text. We need one for our normal score. Let's just start with this one first because we can then duplicate it for the others because they're very similar. I'm going to anchor this to the top right corner. So I'm going to click this diagram here. I'm going to anchor it to the top right. Now, if I set the position to 0, 0, it gets set to 0, 0 relative to that corner. Now I still need to adjust other settings. It's not quite right. So I want to right align it. I also want to it's already top aligned by default. I'm going to disable word wrapping. The font size I'll leave. I'm going to change the color to also be the same dinosaur color, that grayish color. I'm going to drag in our fonts that we used to there. By default, the text will be, let's say, 5 zeros. Now I need to set the pivot point on the X and the Y axis to be 1, which is going to change my position. But now if I set those back to 0, there we go. So the pivot point's in the top right corner. So the top right corner is now at 0, 0. And then the thing as a whole is anchored to the top right corner of the screen. So that's how it gets lined up. Now, I still don't want it to maybe be exactly at the corner. So maybe I adjust these to be something like that. And that looks good. Okay. So from here, that's our score. I'm going to duplicate this. I can right click and duplicate it. I'm going to change this one to high score. And I'm just going to shift it over some more. Let me see what value I use. Feel free to just kind of adjust it till it's shifted over. Make it a 256. And I also want a little label that just says hi. So I'm going to duplicate this as well. Let's change the text to just be HI. And I'm going to adjust the position of this as well. I'm going to set the position so there's an exact amount of space between the different labels. Now, this font that I'm using, I chose very specifically because it's actually a monospace font, which means that no matter which character you're using, they're all exactly the same size. And that's really convenient for things like this. Normally speaking, let's say the character 1 is really skinny, but in this case, it's all the same. So here, actually, I'll do this. Let's reset the asset back to normal. If I change, let's say the 1 to, I don't know, a 6 or a 9. Oh, actually, okay, I guess this built-in font that they use is also monospace. So never mind, that doesn't even matter. But the certain fonts that aren't monospace will be, it's going to change the entire size of this based on, what characters you're using. So if the whole thing was, let's say 1s, it'd be really skinny. But then it's going to make it so none of the text lines up. It won't line up right, just depending on the sizes or depending on what characters you're using. So the monospace font just makes it so it will always kind of perfectly be aligned, and even as these numbers change, it won't change position or change size or anything. So doesn't necessarily matter, but that just kind of helps make it visually a little bit better. All right. Now, one thing we might want to do that I probably should have did earlier is change our scalar properties. So typically I typically don't want to use constant pixel size. What that's going to do is, depending on your screen size, or if we change this, it'll scale with your screen size. That's how the UI is able to adapt to different, let's say mobile devices, landscape versus tablet. If I do scale with screen size, and then I can maybe set my reference resolution to 1920 by 1080. And I like to usually do right around in the middle here. So it'll try to match half of the width and half of the height. This makes it so, depending on what my resolution is, it kind of adapts a little bit better, the UI. So you can adjust that to your preference. Maybe in my case, I actually want to do 1280 by 720. And I think that works a little bit better. Yeah. So it's a small detail, doesn't necessarily matter, but it just helps. Okay, anyways, I'm getting sidetracked a little bit. Now we have our score. Let's go back to our game manager. Let's add some more references to those text components. So text mesh, pro U GUI, score text, and then we also want another one for our high score text. And let's add some variables for the score itself. So let's add a float for our score. I'm using a float. Typically, I'd use integers for things like this, and in the UI, it's just going to be integers. But I actually want to use a float here because the score is sort of based on time, and with time, you might have milliseconds. It's not just perfect 1 second, 2 second. It's going to be 2.4 seconds, 2.5 seconds, 2.6 seconds. So it's actually we're going to be able to calculate our score better using a float. But when it shows up in the UI, it'll just be an integer. So for our score, we're going to increase our score in update, very similar to how we increase our speed in update. So here, we're going to increase our score based on the game speed times time.delta time. So as our game gets faster, you're going to get more score as well. So when the game is really slow, it's a lot easier, so you don't accumulate as score as quickly. But once the game starts speeding up and it gets really fast, that makes it more difficult, which also means you should gain more score. It also makes sense too because you're moving faster. So you can think about score almost as like how much distance have you traveled. And if the game is moving faster, well, that means you're covering more distance in less time. So your score should go up faster as well. There's no specific, like you can of course customize this if you want it to just be like, you know, increase by the same amount per second. Like you could do that. But I personally like it like this. Now, anytime our score changes, we need to update our score text here. So we can say score text.text equals score to string. But once again, this is a float and we need to convert it to an integer. So what I want to do here is say mathf.round to int, pass in our score, and then we'll convert it to a string. And in my case, I actually want to floor this instead of round it. Rounding will go up or down. Flooring it will always round down. So I feel like that works better. It doesn't really matter, but yeah, I like that better. Now this, we're actually do one more thing, but let's take a look at what this looks like. You're going to notice a problem pretty quickly. Oh, well, I got a null reference exception because I forgot to assign my references. Let's drag those in. Oh, yeah, actually that's good. Let's test this again. All right, so notice how I lost all those zeros. So, I mean, this works, but it's not quite what I want. I actually want it to say like 00037, you know, so I want it to keep all the padding, all those leading zeros. So C# actually has a very simple way we can do this. When you convert a number to a string, you can provide a format. So I could say D for decimal, and then I can say 5 to indicate that there should be 5 digits. Or I think D is for decimal, maybe it's for digit, but yeah, basically I'm saying I want there to always be 5 digits displaying. So now it'll automatically add those padding zeros to make sure that it always shows the full thing. So there we go, that looks great. Cool, so that's our score. And once again, as our game speed increases, so will our score. This might be hard for me to do while I'm trying to not get hit, but yeah. So as our game speed increases, our score is going to increase as well. And that was obviously, you don't want the game to increase that quickly, but yeah. So there you go, that's our basic score. And finally, let's do high scores. So this is actually something I don't think I've ever done in any of my tutorials yet, but how can we save what your high score is? Even if you close the game and come back to it later. We want to keep track of those high scores. So for one, we need to update the high score that shows up both when you start a new game and when you finish a game. In case you've beaten the high score, we want to update it. And also when you start a new game, if it's the first time you're playing the game for that session, then it needs to update. So since we're going to do it in 2 places, why don't we add a function that we can reuse? So I'll just say that update high score. And I'm going to call this in both new game and in game over. So in our high score, we can save the player's high score to using something Unity calls player prefs. So we can say player prefs. Based on Unity's description here, they say it is a class that stores player preferences between game sessions. It can store string, float, and integer values into the user's platform registry. So this allows us to save some data, and even if they close the game and come back to it, you know, let's say the next day, that data will still be there. So we can reload that data and display their high score. So what we should do is get their current high score and compare that to their current score. And if their new score is greater, we need to resave that high score and proceed. So let's get their current high score. We're gonna say player prefs dot get float. So we're gonna save it as a float because our score is a float. We need to provide a key to indicate, you know, what we're saving this as. So it's just like some identifier to know like what this variable is in the player prefs. So I'm just gonna call this high score. And then we pass in the actual value we want to, or no, this is, so we're getting the score right now. But in the case that there is no data saved, what should the default value be? Well, the default then should be 0. So let's check now. If their current score is greater than the high score, well, then we want to update the high score to be their new score. And then we want to resave this again. So we're going to set this float. So we're gonna, instead of getting, we're going to set now. We're going to use that same key. We want to make sure we save it under the same thing. And we're going to pass in the value we want to save. High score. And then, of course, we want to update our high score text as well. And we're going to use the same kind of code we used here. But this time we'll pass in our high score. So we're formatting it the same way. And that's it. All right, so let's play this. So it's 0 because I've never set a high score yet. This is my first time playing. Now that we've added that code. So let's say I get, 56, boom. So you saw it got updated because it runs that code on game over. When I restart now, we found a bug. My score didn't reset my score did not reset after we got a game over. So I'm glad we found that because that was just something we missed from before. Whenever we start a new game, we need to reassign the score. So let's set our score back to 0 here in new game. So that's pretty important. All right, let's try that again. All right, so yep. So look, notice how it loaded my high score. It shows 56, which is accurate. Let's try to beat that now. Or let's not beat it. So it stayed at 56. Nothing changed because I didn't actually beat it. Let's actually try to beat that high score now. And there we go. So we've beaten our high score. Now it doesn't update until the game ends. So we get a game over. Now it updated to 85. That's our new high score. We restart, starts at 0 again. There we go. So that's our high score. And once again, even if I close the game and reopen it, that high score will still load. So I restart the game. It still saves that 85. That 85 is saved to my system. So I can reload that over and over again. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel for more videos just like this one, and leave a comment recommending what you would like to see next. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including access to the Unity assets that I develop. Link in the description of the video. Thank you for watching. See you in the next one.